Hello everyone, welcome to MK Maths. I am Karthik Mansale. In previous video we have discussed about the types of function definition with examples. If you have not watched those video, please check my description. I have mentioned links in my description so that you can watch all types of functions definition with examples. So I have covered one function, onto function, many one function, into function, bijective functions, all those things in previous videos. Today we are going to focus on the 5 marks question which may arise from the topic functions. Definitely we can expect a 5 marks question. So to solve the 5 marks question, we should know about the definition of one function, and we should know about the definition of onto function and as well as the bijective function. So if you understand the definition of one and onto function, then our aim is to apply. Now our aim is to apply for this question to solve a 5 marks question, and in 5 marks question they're going to ask to show or state whether or check whether the function is one onto or bijective, like those questions they will ask. So now our aim is to our main aim is to solve the or show the f is a one onto or bijective function. Okay, so to show one function we already know about the definition, but we can't apply a definition directly to the given question. So we have to build a concept. We have to build concept from the definition, and we have to apply that concept to this question. Then we are going to solve the 5 marks question. Okay, so first let us build the concept of one and also let us build the concept of onto. Then it will be easy to solve any question. So if you understand this question clearly, if you understand this question without any doubts, then definitely we can solve any 5 marks question from this topic, because every pattern will be same, every question will be same method, same way to solve a one and onto. But first we have to understand the concept. So before going to this question, so here first focus, we have to one and we have to show onto, or we have to check bijective. Okay, bijective means if it is a function satisfy both one and onto, then we can easily say bijective function. So first focus only on one and onto. If you build a concept, if you understand the concept, and if you apply that concept to this question, then definitely we can solve a one and onto. So let's build a concept and understand the concept of one here. So one function. So we already know that one function is nothing but one-to-one mapping. Okay, one-to-one mapping. This is one-to-one mapping function. Sometimes we call it as a functions also mapping. Mapping means we are mapping from domain to codomain. No? So that meaning it comes. Mapping means. Okay. So now I consider a domain here. This is domain and this is codomain. Okay, so this is A and this is B. This A is nothing but domain, this A is nothing but domain, and this B is nothing but codomain. This B is nothing but codomain. Okay, so now next so to show one function, or it given function is satisfying one or not, means first we have to check the definition. So what the definition says, every element of a, no, so for the sake of simplicity I consider two elements, so that is nothing but x1 and this another point is x2. Okay, so I have considered this 2 points here. So I have considered 2 points. This first point is nothing but x1 and this second point is nothing but x2. Okay, so every element of a, so it should satisfy the definition of a function, because the first if the function if the given f satisfies the definition of function, then only we can verify one. So if the question has given a f, means definitely the given f will be already a function. So the function definition says every element of a has one and only one image. So it means there should be a image for x1. If I created a x1, means if I created a x1, if there is a, if I consider there is a x1 in a, then definitely there should be a arrow mark. If there is no arrow mark, then it will be not a function itself. Okay, so to create a function, to become a function, first there should be a arrow mark. So I have created this relation x1 having this arrow mark which is related in b. We call it that as f of x1. In previous video I have already mentioned, we denote the function like this, f of x equals to y. This x is nothing but a domain part, this y is nothing but a codomain part. So this x1, x2, x3, all those things are in domain, and f of x1, f of x2, f of x3, all those things will be in codomain. F of means after the function applied, so it moves to codomain. The relation started in domain and it ended in codomain. So this x1 is the domain, f of x1 is in codomain. F of x1 is nothing but range here. So for x1 having the function f of x1, okay, f of x1 will be in codomain, and for x2 also there will be a function, in codomain. So that point will be now f of x2, because every element of a has one and only one image, they should be satisfied, because if it is not satisfying then it is not a function. So to become a function, first it has to satisfy every element of a has one and only one image. So x1 having the image f of x1, x2 also having the image f of x2. Okay, but now our aim is to show the given function is 1 1 or not. So if you want to show the given function is 1 1 or not, means we have to verify. Now we have to verify the 1 1 function definition. 1 1 function definition says every element of a has one and only one unique image. To check that unique image part, now we are going to change this. So here x1, x2, so this is x1 and this is x2. So x1 having this f of x1, now I try to assume these two are equal. To check the 1 1 function definition, I am going to assume myself, I am going to think myself, these both, the f of x1 and f of x2 are equal. If these both are equal, means what will happen? So that I have to see now. So now I have made these two are equal now. So f of x1 equals to f of x2. Now I have made f of x1 equals to f of x2. So now x2 will also mapping to this point only. Now this f of x1 and f of x2, I made a one point, I have created a one point. So now our main focus is in codomain part, we have made f of x1 equals to f of x2. So in domain part we have considered a x1 x2, and in codomain part we have considered a f of x1 f of x2, and we made those codomain elements f of x1 and f of x2 equal. Now if we made these two are equal, then what will be the domain part? X1 and x2, how the x1 and x2 will behave? If x1 and x2 is not equal, then we can say it is many one function. See here, many to one is there. So if when I made this f of x1 equals to f of x2, when these 2 points become 1 point equal, then automatically this x1 and x2 will also become equal, means x1 equals to x2, then there will be a 1 to 1 relation, 1 to 1 mapping, 1 to 1. So suppose if I made this f of x1 and f of x2 equal, spontaneously here x1 x2 will also become equal, means then it is a 1 1 function. After considering f of x1 f of x2 equal also, if x1 x2 are not equal, then it is nothing but a many one function. If we made these two equal, then automatically if these two become equal, then it is a 1 1 function, 1 to 1 function. For one point there will be one arrow mark, for one image there will be, for one point in domain there will be a unique image in codomain. So if you after making equal, after assuming these both f of x1 and f of x2 are equal, then these two are not changing, these two are fixed here, x1 and x2. If these two are not equal, then it become a many one function. It means not 1 1 function. Many means x1 x2 are many to 1, it's going to only 1 point, 2 points are going to 1 point. So if 1 point to 1 point means 1 1, this is 1 1. If 2 points to 1 points like this, if there exists any like this, there will be no unique image, then it is not 1 1, it is not 1 1. Okay, many one it will become. So our main target is assuming f of x1 equals to f of x2 means codomain part. In codomain elements, if I assume both are equal, then what will be the domain part? If domain part also become equal, then obviously it is a 1-1 function. If domain part not become equal, then it is not 1-1 function. Okay, I hope you understood the concept. Now let us solve the problem now. So here, so first 1-1 solution we have to check for 1-1. Okay, we have to check for 1-1. So let first our main to check 1-1 means we in while explaining the definition of 1-1 I have mentioned 1-1 means we only focus on domain. Here domain is nothing but R, first R. Codomain is nothing but second R. Okay, so here first let us consider x1 comma x2 belongs to R. x1 comma x2 belongs to R means we already know it is a real number. Okay, so this is domain, first R domain, this R. So this R I have considered from this real number. There are infinite numbers, uncountable. Real number is uncountable, no? So in these infinite numbers I have considered two elements, x1 x2, to verify it is a 1-1 or not. So that is our aim here. So I have considered x1 comma x2 belongs to R here. Next my aim is to see here, if x1 exists in domain means there will be a element in a codomain f of x1, there will be a range. So f of x1, if there exists x2 in a domain, for that element there will be a range f of x2 in codomain. Okay, so here for domain this is R, this is codomain R. So now x1 here is there, x2 I have considered 2. For x1 now we got f of x1, for x2 we have got f of x2. Okay, for x1 we are having a mapping f of x1, for x2 we are having a mapping f of x2. Means every element of A has one and only one image. So that condition is satisfying here because f is a function. They have given f is a function. So next our main target is suppose so I have used the word suppose here. Suppose f of x1 equals to f of x2, f of x1 equals to f of x2 now. So what is f of x1 here? See, if f of x is they have given in question, there will be a function mapping from R to R domain, codomain, and function value will be in question itself. So f of x having 3 minus 4x. In the place of x we have to write, see here, 3 minus 4x, 3 minus 4 times of x. In the place of x now we have got x1, so we can write 3 minus 4. In the place of x we got x1, so here I am writing x1. 3 minus 4x1 equals to 3 minus 4x2. In the place of x we got here x2. So the question is 3 minus 4x. So f of x1 become 3 minus 4x1 equals to f of x2 become 3 minus 4x2. Now we can cancel, which are left hand side, right hand side, both are same. We can cancel now. So here this 3 and this 3 can cancel. So next step will be minus 4x. Okay, minus 4x minus 4x1 equals to minus 4x2. Now again we can cancel. So here again we can cancel this minus and this minus and this 4 and this 4 we can cancel. So now we got x1 equals to x2. Now we got x1 equals to x2. I hope you understood the concept of 1-1 here. So suppose this part we have created here. Suppose f of x1 equals to f of x2. I have assumed it. To check the given function is 1-1 or not, so I have made these two, f of x1, f of x2, which are in codomain. I have assumed both are equal. If you assumed these both are equal, then simultaneously after solving I got the answer x1 and x2 are also equal. If you means x1 is related to f of x1 and x2 is related to f of x2. So if those f of x1 and f of x2 become equal in codomain, then x1 x2 will also become equal in domain. Then it means 1 to 1 relation is there. So here we can write therefore given f is 1 function. Therefore the given f is 1 function. So whatever the question may be, if they ask to verify the given function is 1 or not, or show that the given function is 1, then definitely use this concept. First concept is we have to consider two elements from the domain. So I have considered x1 comma x2 belongs to R here. After considering a two elements domain, those two elements having a two images in codomain. So those for x1 having a image f of x1 in codomain, x2 having a image f of x2 in codomain. Next step is we have to assume both are equal. We have to consider it. So suppose I have written the keyword here, suppose f of x1 equals to f of x2. Now f of x1 changes to f of x, they have given 3 minus 4x. Now f of x1 changes to 3 minus 4x1 equals to 3 minus 4x2. If we cancel 3 and minus 4. So now at last we have remained x1 equals to x2. F is 1 function. I hope you understood the 1 function here. Okay, in same way we have to build a concept of onto. Now what will be the onto? Okay, so let's build a concept for onto, then it will be easy to solve. Okay, onto. So what is the concept of onto? Here onto definition, previous video I have explained. Onto definition says every element of B, so it starts from the codomain. Okay, so this is A, this is B, this is codomain, and this is domain. This is domain. Okay, so onto means we have to focus on this codomain part. 1 means we have to focus on domain part. So that is the first main thing to observe here. So when it comes to onto, I just focus on codomain here. In codomain I consider the y. In codomain I consider this point as y. Now this point as y. Okay, so now our aim is to verify the given function is onto. Okay, so onto definition says every element of B for all B has at least one pre-image in A. Reverse we have to go now. Pre-image means I already explained, so reverse way we have to go. So now for I have considered y, for every element of B means for this y also there should be a one reverse thing, the reverse arrow mark. Okay, so actually the arrow mark will come from A to B, no? So I am going in reverse direction. When I go in reverse direction, I should get there in domain, I should get one x value. If I got x value, then it is a onto function. For y, when I go reverse, if I got x value in domain, then it is onto function. When I go reverse, if I not got x value in domain, then it is not onto function. So this is concept here. So I will explain how to go reverse and how to solve to reach x here. Okay, so first understand the concept. First we have to consider the element in codomain. So this is the first step. We have to consider the element in codomain. Okay, y. After considering the codomain, just think there will be a x in a domain. If you consider x, the x image for the x, the image is this point. This point you considered as a y now, but actually if you go from a domain x, we call this point as a f of x. Yes, no? So in previous x1 for the image there will be f of x1, for x2 there will be image f of x2. So similarly for x, if you go, there will be the image name called f of x. For x, the image name is f of x. Now I have considered that same point as y now. Okay, so now both are same. So this y and f of x are same here. Y is nothing but a indication the elements which are in B. X is nothing but a indication that elements which are in A. Okay, so for X, if you go, the image will be named as a f of X. For that same f of X, we name it as a Y here. It means what you have considered Y and what it is f of X, both are same here. So a Y equals to f of X. So next, after considering a Y, we have to equal what we have considered Y and what they have given f of X, both are same. So y equals to f of X. After solving this, we can reach X. So if you got X value, if this X is present in domain, then it is onto. If this X is not present in one domain, it is not onto. So this is the concept. I hope you understood the concept. Now apply the concept to our question here. Okay. Now apply this concept here. So now onto. Okay. Onto. For onto, let us consider. See here first. Us consider let us consider y. Let us consider y. So y means here which is in codomain. So y belongs to R. So this R is nothing but codomain. This R is nothing but codomain part. Okay, I hope you understood. The codomain part here means second element. From a second set, I am considering a Y and I am reaching to first set domain. If there is a element in a domain, then it is onto. If it is not there, then it is not onto. Okay, so Y belongs to R codomain. Next, we already know I have considered this Y. They have given the function f of X. Both are same. Okay, so if you go from X to codomain, means you call it as a f of X. I have considered that point itself as a Y now here. So y equals f of X means the question itself is there, 3 minus 4x. Now we have, our aim is to find X. So I make it X as a separate and remaining elements are separate. This minus 4x transferred to left side means now it becomes plus 4x equals to 3, and this y if you transfer to right side means it becomes y, 3 minus y now. 4x equals to 3 minus 1. Then x equals to 3 minus y divided by 4. 3 minus y divided by 4. So if you observe here, x and 4 is multiplying here. For x, 4 is multiplying here. If you transfer this to right side, then it become a division now. So it looks like a fraction part. So fraction part is nothing but a x value. So x value, we know that x values are always in a domain. If you check the domain is a real number. So it means fraction part is always a real number. So it belongs to real number R. So belongs to real number R here. So we can write we can write here one sentence. For all y belongs to R, for all y belongs to R, there exist x equals to 3 minus y by 4, 3 minus y by 4, which is belongs to R, such that f of x means here 3 minus y by 4, which is equals to y. For all y belong means I have writing a sentence here. See here, for y belongs to R, we have considered, no, I have written the sentence. For all y belongs to R, there exist x. We got x. For all any y you have considered, there will be x here. X equals to 3 minus y by 4, which is belongs to R, such that f of x means 3 minus y by 4 equals to y. Therefore f is onto. Here f is 1 1. Here f is 1 1. So now easily say that hence f is bijective. hence f is 1 1 and f is onto, hence we can say f is bijective. So I hope you understood the 1 1 and onto concept here. So in next video also I am going to explain some more 5 marks questions. So in that also you can get a clarify. So procedure is same. To find a 1 1 means first we have to consider two elements from domain, and we have to suppose we have to assume that f of x1 and f of x2 are equal, then we have to solve, and if we get a x1 equals to x2, then it is 1 1. If we not get x1 equals to x2, then it is not 1 1. So when it comes to onto, first we have to consider a element from codomain y, and we have to make sure that y is nothing but a f of x. If y equals to f of x, after solving we get a x. If that x belongs to domain, then obviously it is a 1 1 function. If that x does not belongs to domain, then it is not a 1 1 function, and we have to write, if it is belongs to domain, we have to write this sentence. So this sentence is also important here. So for all y belongs to R, so this for all y belongs to R, there exist x, this there will be exist of x 3 minus y by 4, which is belongs to R, such that f of x equals to y. F of x means 3 minus y by 4 equals to y. Then f is onto. Here f becomes the onto. The f is 1 1 and f is onto. Then f is both bijective function. I hope you understood this. In next video also we are going to explain same things in different examples. Okay. So let us all meet in next video.